Welcome back. Today we are exploring cross-lingual transfer, how models learn to work across multiple languages and transfer knowledge between them.
Multilingual models are fascinating because they demonstrate that language models can learn language independent representations.
Let's start with the basics. What makes a model multilingual?
A multilingual model is trained on text from multiple languages rather than just one.
This could be as few as two languages or as many as 100 or more.
Models like Embed, XLMR, and multilingual versions of GPT are trained on dozens of languages simultaneously.
The key insight is that you can use shared parameters across languages rather than training separate models for each.
This has huge advantages. You only need to train and deploy one model, and knowledge can transfer across languages.
But there are also challenges. How do you handle different scripts, vocabularies, and linguistic structures?
Let's talk about tokenization for multilingual models.
You need a vocabulary that covers all languages efficiently.
Byte level BPE or sentence piece work well because they're language agnostic.
They treat text as sequences of bytes or Unicode characters and learn subword units that span all languages.
Languages with more data in the training set tend to get more dedicated vocabulary tokens.
This can lead to imbalance. English might be tokenized efficiently while low resource languages are split into many pieces.
Some approaches explicitly balance vocabulary allocation across languages.
Another tokenization challenge is script diversity. Latin, Cyrillic, Arabic, Chinese, and other scripts all need representation.
Unicode based tokenization handles this naturally, but you need sufficient data in each script for the model to learn good representations.
Now, how does cross lingual transfer actually work?
During training on multilingual data, the model learns representations that capture language independent meaning.
Words or phrases with similar meanings across languages end up with similar representations, even if the surface forms are completely different.
This is because they appear in similar contexts and perform similar functions.
For example, cat in English, chat in French, and gato in Spanish might all have similar embeddings.
This shared semantic space enables transfer. If the model learns to perform a task in one language, it can apply that knowledge to other languages.
For example, train a sentiment classifier on English data, and it might work reasonably well on French or German without any French or German training examples.
This is called zero shot cross lingual transfer.
It's incredibly valuable for low resource languages where task specific label data is scarce.
Let's discuss factors that affect cross lingual transfer.
First, linguistic similarity. Transfer works better between related languages.
English to German transfer is easier than English to Japanese because Germanic languages share structure and vocabulary.
Second, the amount of data per language during pre training.
Languages with more pre training data develop better representations, making them better sources for transfer.
Third, script and vocabulary sharing. Languages using the same script transfer more easily.
And fourth, the nature of the task. Some tasks are more language independent than others.
Tasks based on universal concepts like sentiment transfer well. Tasks that rely heavily on language specific phenomena like wordplay are harder.
Let's talk about training strategies for multilingual models.
The simplest approach is to mix data from all languages and train jointly.
But you need to decide the mixing proportions. Should all languages get equal weight, or should you weight by data availability?
Equal weighting gives low resource languages more influence, for example, which can help them, but it limits exposure to high resource languages.
Data availability weighting means the model sees more of common languages, which might improve overall performance but underserve low resource languages.
A compromise is temperature based sampling, where you raise the language proportions to a power less than 1.
This gives more weight to low resource languages than pure availability weighting, but doesn't fully equalize.
Another strategy is stage training. First, train on high resource languages, then adapt to low resource languages.
Or use curriculum learning, starting with easier high resource languages and gradually introducing harder low resource ones.
Let's discuss cross lingual alignment techniques.
Some methods explicitly encourage cross lingual alignment during training.
Translation language modeling, or TLM, trains on parallel sentence pairs.
The model sees a sentence in one language and its translation in another, helping it learn that they represent the same meaning.
Another approach is to use a contrastive objective that brings together representations of translation pairs.
These alignment techniques can improve cross lingual transfer quality.
Now, what about cross lingual instruction tuning?
You can instruction tune multilingual models on instruction response pairs in multiple languages.
This teaches the model to follow instructions regardless of the language.
Interestingly, instruction tuning in just one language, typically English, can improve instruction following in other languages too.
This suggests the underlying instruction following capability transfers across languages.
But for best results, including diverse languages in instruction tuning helps.
Let's talk about code switching and multilingual contexts.
Code switching is when text mixes multiple languages within a sentence or conversation.
Multilingual models trained on diverse web data often encounter code switching naturally.
They can handle inputs that switch between languages, understanding the mixed context.
This is useful for bilingual users or regions where code switching is common.
What about translation using LLMs?
While specialized translation models exist, instruction tuned LLMs can perform translation through prompting.
You instruct the model to translate from language A to language B.
For high resource language pairs, LLM translation can be quite good, sometimes competitive with specialized systems.
For low resource pairs, quality varies, but multilingual LLMs might still outperform systems that lack data for those pairs.
Let's discuss evaluation of cross lingual models.
XNLI is a cross-lingual natural language inference benchmark in 15 languages.
It tests whether models can understand logical relationships across languages.
XQIT and MLQA are cross-lingual question answering benchmarks.
Xstream and Xstream R are comprehensive multilingual benchmark suites covering many tasks and languages.
These benchmarks test both per language performance and cross-lingual transfer capability.
Evaluation often includes zero shot transfer, train on English, test on other languages to measure transfer effectiveness.
Let's talk about low resource language challenges.
Many languages have little digital text available for training.
This makes it hard for models to learn good representations for those languages.
Strategies to help low resource languages include aggressive vocabulary sharing, transfer from related high resource languages, and augmenting data with synthetic translation.
You can also use monolingual data from low resource languages for continued pre-training.
Another approach is to use linguistic resources like dictionaries or morphological analyzers to inject structure.
Community-driven efforts to create more data in low resource languages are also crucial.
What about language specific adapters for multilingual models?
You can train adapter modules for specific languages while keeping the shared backbone frozen.
This allows targeted improvement for languages without affecting others.
You can also combine language adapters with task adapters for language-specific task performance.
Another consideration is cultural and contextual differences across languages.
Translation isn't just about word substitution. Cultural references, idioms, and pragmatics vary.
Multilingual models need to handle these subtleties, which requires diverse cultural representation in training data.
Finally, let's discuss the future of multilingual LLMs.
There's ongoing work to improve low resource language coverage and quality.
Efforts to create truly equitable multilingual models that perform well across all languages, not just dominant ones.
Research into efficient multilingual architectures that handle hundreds of languages without excessive parameters.
An exploration of multilingual multimodal models that connect text, speech, and vision across languages.
So, to recap, multilingual models train on diverse languages and learn shared semantic representations. Cross-lingual transfer enables zero-shot task performance in unseen languages. Vocabulary and tokenization choices impact multilinguality. Mixing strategies and alignment techniques affect transfer quality, and challenges remain for low-resource languages and cultural nuance.
Next episode, we're diving into knowledge distillation, compressing large models into smaller, faster ones.
Thanks for listening.
Until next time, keep learning and stay curious about AI.